Good morning, students. Today I will be presenting you a lecture on the topic that is implementing inheritance in Java. So let's start with it. Java is a true object-oriented programming language and supports almost all the features of object-oriented programming system. These were the four features of object-oriented programming system, and Java supports all of these. However, Java does not support multiple inheritance. I have already explained you in my earlier presentation that Java supports single inheritance where one derived class inherits the properties of one base class. Java supports multi-level inheritance where a derived class inherits the properties of a base class, which in turn again becomes a derived class when it inherits the properties of another base class. So this form of inheritance is known as the multi-level inheritance. I have also shown that Java supports hierarchical inheritance where there can be multiple derived classes inheriting the properties of a base class. But Java does not support multiple inheritance, where a particular derived class can inherit the properties of multiple base classes. So this type of inheritance is not available in Java. I have also explained you in my earlier presentation that for any data member which has been declared as private as the access specifier, they shall be accessible only within its own class, but not to any class which is outside its own class. In this figure, since the data member's serial node speed and RAM size were declared of type private as the access specifier and they belong to the class computer, that's why they shall be accessible only within its own class computer. They shall not be accessible to any class which is outside of this class computer. In this case, the data member's serial node speed and RAM size, since they are declared of type private as the access specifier, they shall be accessible only within its own class computer, but not accessible to the class user, as the class user is outside this class computer. But if these data members serial node speed and RAM size are declared of type public as the access specifier, then they shall be accessible within its own class computer and also accessible to any other class declared outside its own class computer. Now in this figure, the class user is a class which is declared outside the class computer. Now since these data members serial node speed and RAM size are declared of type public as the access specifier, that's why they shall be accessible within its own class computer as well as to the class user which is declared outside the class computer. This shows that the data members serial node speed and RAM size, when they are declared of type private as the access specifier, they are encapsulated to any other class which is outside its own class computer. But when they are declared of type public as the access specifier, then they shall be accessible to any other class which are declared outside its own class computer. Now consider this figure where you have one base class computer and two derived classes user1 and user2. These two derived classes user1 and user2 acquires the properties of its base class computer through inheritance, and this form of inheritance is known as the hierarchical inheritance, as this figure looks similar to this one, which is hierarchical inheritance. There is another class specified by the name user3 here, which do not inherit the properties of the class computer. So I have separated this class from these three. Now for the class called computer, look at these data members. These data members are not declared of type public or private as the access specifier. They are declared of type protected as the access specifier. Now, as I have already explained you that protected members of a class are accessible to the inherited classes only, that's why these data members, that is serial no speed and RAM size for the class computer, since they are declared of type protected as the access specifier, they shall be accessible within its own class computer as well as to the classes user1 and user2, which are the inherited classes for the class computer. But these data members shall not be accessible to the class user3 because the class user3 is not an inherited class of the class computer. Then I have also explained you about the friendly access specifier. Now look at these classes, class A, class B and class C. They fall under the same package, and since these classes falls under the same package, that's why their members are mutually accessible to each other. That means the members of the classes A, B and C shall be mutually accessible to each other. But for the class D, since it has been declared outside of this package comprising of class A, class B and class C, this class is a standalone class and their members shall not be accessible to the classes A, B and C. So that's what has been clearly said here. The classes A, B and C comes under the same package, so their members are mutually accessible to each other. But class D is outside of the package, so the members of class D are not accessible to the classes inside the package. I have also explained you in my last presentation that the members of a class are friendly by default. That means if you do not provide any access specifier for the data members, then by default the data members will be given the friendly access specifier. Now if you look at this figure, for the class computer, the data members serial no speed and RAM size were assigned the protected access specifier because it has been explicitly specified here. But for the classes user1, user2 and user3, look at their data members. They have not been assigned any access specifiers. So by default, these data members will be assigned the friendly access specifier. Now coming back to today's presentation, the extends keyword is used to inherit a base class by the derived class in Java. Now the syntax of inheritance in Java is like this. At first you have to specify the derived class name followed by this extends keyword and then the base class name. So from this statement we can clearly understand that when a derived class wishes to acquire the properties of its base class, it has to use this extends keyword. So using this extends keyword, the derived class will be able to acquire the properties of the base class. And this is the body of the derived class. So inside this body there will be some set of Java statements which are to be executed, and the body of the derived class is specified by the opening curly brace and then the closing curly brace. Inside this opening and the closing curly brace there will be a set of Java statements. Now I am going to show you a program in Java to calculate the areas and perimeters of a rectangle and a square using the concept of inheritance. And here is this program. At first, a class specified by the name shape has been declared. So here is this class specified by the name shape. Then two data members, that is area and perimeters of type float and int, has been declared, and they come under the protected visibility mode. So that's what has been specified here. These are the two data members, areas and perimeters of type float and int respectively, and declared under the protected visibility mode. Then there is one member method specified by the name calc of return type void and access specifier public. But this member method does not have any statements to be executed inside its body. You can clearly see its body is empty. And this member method, that is calc, is specified here in the third compartment for this class shape under the public access specifier section. And since its return type was void, so it's declared like this, void calc. Now there is another class rect which inherits the properties of its base class shape using the extends keyword. So this class rect is the derived class and the class shape will be the base class. And this is clearly shown here. The derived class rect acquires the properties or inherits the properties of the base class shape. Now this derived class rect has two data members, width and length, declared of type int and private as the access specifier. So that's what has been mentioned here. The two data members width and length are of type int and they are declared under the private access specifier section. Then there are two member methods. The first one is rect okay. The first member method is rect, having two arguments w and l, and the second member method is void calc. Now if you look at these two member methods, that is rect and calc, you will notice that the name of the first member method rect also resembles the name of the class, which is also rect. That's why such type of member methods whose name resembles the name of the class are known as constructors. So let me comment on this. Let me comment on this method that this is a constructor. But this member method is not a constructor because its name is calc, which do not resemble the name of the class, which is rect. So they have been declared here in the third compartment. The first one is the constructor rect, as it resembles the name of the class, and the second one is the member method calci. They have been declared under the access specifier public section. This is because here in this program the constructor has been declared of type public as the access specifier, and even the member method calci have been declared as public as the access specifier. Then look at here, they have declared another derived class square which acquires or inherits the properties of the base class shape using the extends keyword. So this is what is shown here. The derived class square inherits the properties of the base class shape. Now see, come inside this class. At first they have declared a data member called side of type int having private as the access specifier. So this is what is shown here. The data member side of type int is given the access specifier private. Then they have declared two member methods. The first one is public square, then with s as the argument of type int, and the second one is public void calci. Now look at the first member method. The name of the first member method is square, and since it resembles the name of the class, that's why this type of member method is known as the constructor. I have specified it using a comment line. Then come to the second member method. Its name is calci, which do not resemble the name of the class, which is square. That's why this type of member methods are not constructors. And both these member methods calci and the constructor square are declared with the public access specifier. So that's what has been represented here. The constructor square for the class square is under the public access specifier section, and the member method calci is also declared under the public access specifier section. Now these three classes, that is shape, rect and square, are in a way connected with each other. This is because the classes rect and square inherits the properties of the class shape, and that's why the classes rect and square are the derived classes for the base class shape. But this class inheritance demo, okay, look at this class inheritance demo. This is a standalone class. It does not acquire any properties from the class shape. So this class inheritance demo is not connected to these three classes, that is shape, rect and square. Now if you look at this Java program, this class, that is inheritance demo, contains one method. This is the main method. Now we already know that the starting point of execution of a Java program starts from the main method. That's why the starting point of execution will start from this class, that is inheritance demo, as this class contains this main method. The main method is represented using the statement public static void main, and within bracket they have the argument args of type string. Then the body of this main method consists of these sets of Java statements, and this set of statements are inside the body of this main method. The body of this main method is represented by the opening curly brace and then a closing curly brace at the end. So now let's execute this main method. Come inside this body, see the first line. The first line creates an object R of the class rect. Now as soon as the object R of the class rect has been created, the constructor for this class rect shall be invoked or called. So from here we'll shift to this class rect and we are going to find out the constructors. Now out of these two methods, this is the constructor, as its name resembles the name of the class. Now we shall execute this constructor. This constructor possesses two arguments, w and l, both of type int, as shown here. Now see, as soon as this object R for the class rect has been created, two arguments have been specified, that is 4 and 5. The first argument 4 will be passed to W, and the second argument 5 will be passed to L. So W gets the value 4 and L gets the value 5. So when width equal to W, 4 will be assigned to width, and when length equal to 5, 5 will be assigned to length. And once width gets the value 4 from W and length gets the value 5 from L, the control will again come over here. Then it will move to the next line, that is here. Then again, using the same object R and the dot operator, it will call the member method calci. Now again, come to this class rect. Now find out the calci method, because with the help of the object R, it is calling the calci method using the dot operator. So this is the calci method. Now execute this calci method, come inside this body, see the first line. The first line says area equal to width into length. So we know that the value of width was 4. So I will just specify 4 for width, and again the value of length was 5. So I will specify the value 5 for length. So 4 into 5 is 20. So area will now be assigned the value 20. Then come to the next line. It says perimeters equal to width plus length into 2. So we know that width was 4 and length was 5. So 5 plus 4 is 9, and 9 into 2 is what? 18. Now perimeters will get the value 18. Then come to the next line. The next line says system.out.println, and within bracket they have printed the text rectangle, and this is within inverted comma. So in Java, whatever text is printed within inverted comma, they will get displayed in the output exactly as it is. Now system.out.println will display the text rectangle as it is in the output. So this is what is shown here, the text rectangle getting displayed as it is in the output. Then come to the next line. It says system.out.println, within inverted quote you have the text area equal to. So in the next line, the text area equal to gets displayed exactly as it is. Then something has been added to this text. What has been added? The value of the data member area. So what is the value of the data member area? It's 20, which we have already calculated from this expression. So 20 will get displayed in place of the data member, which is area. Then again come to the next line. This line, that is system.out.println, this time it prints the text perimeters equal to, because this text perimeters equal to is also within inverted quote. So again in the output you will see the text perimeters equal to getting displayed exactly as it is. Then something has been added to this text. What has been added? The data member perimeters. The value of this data member perimeters is calculated and found to be 18 from this expression. So in place of this data members perimeters, what gets displayed in the output is 18. Now once the body of this member method gets executed, the control will come here, and then from here it will move to the next line and it will execute this statement. In this statement, they have first created an object S for this class square, and an argument 5 has been specified for this object S. Now see, as soon as this object S for the class square has been created, the constructor for this class square shall be invoked or called. So from here again we shift towards here, so we come to this class square, and then we are to find out the constructor. Now out of these two methods, that is public square and void Kelsey, which one is the constructor? Now the first method, public square, then within bracket they have the argument S of type int. See, this method has the name square, which also resembles the name of this class, which is also square. So that's why this type of method is a constructor method, and I have specified using a comment line here. Now if you look at the second method, Kelsey, its name does not resemble the name of the class, which is square. That's why these types of method are not the constructor methods. They are the usual member methods for a class. So for the class square, it's this method, that is public square int S, which is the constructor method. Now as soon as the object S for the class square gets created, the constructor for this class square will get invoked, and for this class square, this is the constructor. So this constructor shall be invoked, and we know that the argument that has been passed was 5. So now argument S will now get the value 5. So the value 5 from S will now be assigned to side, and as a result the body of the constructor closes after having assigned a value of 5 to the data member side. Now again, after executing this constructor, the control will shift, come over here, and then it will move to the next line, and again using the same object S, it calls the member method Kelsey using the dot operator. So again from here the control will shift to here, it will call this member method void Kelsey declared of type public as the access specifier. Now come inside its body, execute the first statement, that is area equal to side into side. So what will be the value of area? We know that the value of side was 5. So when area equal to side into side, where if side gets the value 5, then area will be equal to 5 into 5. So 5 5s are 25, and since 5 5s are 25, so now area will get the value 25. Again come to the next line, it says perimeters equal to side into 4. So we know that the value of side was 5. So when perimeters equal to side into 4, perimeters will actually become 5 into 4. Now 5 into 4 is 20. So now perimeters will be assigned the value 20. Now come to the next line. It prints the text square using the statement system.out.println, and since the text square is within inverted code, it will be displayed as it is in the output. That's why this was the previous line, and then in the next line it's going to print the text square as it is in the output. Then come below to this line. It prints the text area equal to within inverted code. So since this text area equal to is within inverted code, it will be printed as it is in the output. So in the output, the text area equal to gets displayed as it is. Then something has been added to this text area equal to using this plus operator. What has been added? The data member area. Now what's the value of this data member area? We have already calculated the value to be 25 from this expression. So in the output, along with this text area equal to, the value 25 has been added. Again come below, move to the next line. The next line prints the text perimeters equal to, which is enclosed within inverted code using the statement system.out.println. So the text perimeters equal to gets displayed exactly as it is in the output. Now also something has been added to this text perimeters is equal to using this plus operator. So what has been added? Again, the data member perimeters. So since this data member perimeters holds the value 20 that is calculated from this expression, that's why in the output, along with this text perimeters equal to, you see the value of the data member, which is perimeters. Now this ends this member method calc. Now after executing this member method calc, the control again shifts from here to here, and with this the main method ends with the closing curly brace, and once the main method ends with the closing curly brace, the class inheritance demo also ends with this closing curly brace. So that's the end of this program, and the output that we got is this for the program. Now remember one thing, that these data members area and perimeters were declared of type protected as the access specifier inside this class shape. That's why these data members area and perimeters comes under the protected access specifier for this class shape, and this is represented here in this format. Now once these data members have been declared of type protected as the access specifier, they shall be accessible only within its own class shape, and they shall be also accessible to the inherited classes rect and square, but they shall not be accessible to the class inheritance demo. This is because the class inheritance demo is not an inherited member for the class shape. That's why you can see in this program that these data members area and perimeters, since they were declared of type protected as the access specifier for the class shape, that's why they could be accessed only by these derived classes rect and square inside their member method calc as represented here. Okay, they have been declared under the member method calc, where these data members area and perimeters are accessed inside the classes rect and calc. And since these data members were declared of type protected as the access specifier, they shall not be accessible to this class, that is inheritance demo. That's why you don't see area and perimeters assigned any values inside the main method of this class inheritance demo. But you can see that these data members were assigned some values using some expressions inside the derived classes rect and square, because these derived classes inherits the properties of the base class shape, and in turn it inherits the data members which have been declared of type protected as the access specifier. So remember this concept of inheritance. So with this I end the presentation today.